Hi everyone. So this is a new question. Let me get my papers first. Let me see. Question 6. Yeah. So this is a new question. What are we looking at? Question 6. State which of the following sets of data are discrete. So remember guys, we have looked at two kinds of data sets. We looked at discrete. Oh, this is quite thick. Make it smaller. Okay, so I'm gonna delete this stuff. So we've got discrete and continuous, right? So discrete was, for example, with the binomial distribution, and continuous is with the normal distribution. So normal is, for example, the height of kids in school, for example. So continuous is something that we measure. Okay, we measure, for example, your height, and you can be 160 centimeters, but you can also be 160.001 centimeters. And so that's really on the whole line. It's not discrete. It could be anything on the line. Whereas discrete, you're counting. So discrete, you're really counting something. So it could be with the binomial, for example, indeed, how many times is your crush going to reply? Is it 0 times? Is it 1 time, 2 times, 3 times, 4 times, or 5 times? Remember, if we text your crush once a day for 5 days, that is discrete. So remember, discrete is counting, continuous is measuring something. Okay, so what is the question? State which of the following sets of data are discrete. So the first one, speeds of cars traveling along a road. Well, the speeds, again, could be anything, right? It could be 50 kilometer an hour, but it could also be 50.3 kilometer an hour, or it could be 81. So this is really measuring. So this will be continuous. So this is not discrete. What about the second one? Number of members in family. Well, that is discrete, isn't it? Because we can count. We can have a number of members in families. Could be 0, could be 1, could be 2, So that is discrete. Third is maximum daily temperature. Again, this is something we measure. Maximum daily temperature. This could also be like 23 degrees or 23.5, whatever. It could be anything. So that is continuous. Okay. And then 4. So that's still not discrete. 4. Height of people in a class measured to the nearest centimeter. Okay, so normally the height would also be like continuous, right? Because we measure something. But now, as they say, measure to the nearest centimeter. So there is some restriction. So it could be 160 centimeter, or it could be 161. And that is a finite set, the possibilities. So essentially it could be between, 0 centimeter up until, 250 centimeters, suppose, like the biggest person on Earth. I don't know how big that is, but so if you measure to the nearest centimeter, then this would be discrete, because it is not like, it can't be anything. You know what I mean? It's kind of a discrete number. And then 5, daily intake of protein by members of a sporting team. Intake of protein, again, that is really measuring again. So protein intake, that is also continuous. So it's not discrete. So to conclude, what is discrete? Well, this one and this one specifically, because they say measured to the nearest centimeter. So in that case, we could see it as discrete because it's kind of finite, you see. Like this. But if they would have said only the height, then it would be continuous. because then it could be 160, but also 160.1 or 160.01. You know, like there are infinitely many possibilities. So that's why it would be continuous. Okay, so that is question A. Oh, what happens here? Let's move on to the box plots. Okay, so how do you feel about this box plot? I hope you feel confident about these ones. So how does a box plot work? I'm gonna write it up here. Let me just delete this for now. This works pretty nicely. I'm happy with my tablet, guys. Okay, so how does a box plot work? So this is a data visualization. So we've got our axis, and then we've got a box plot. So the box plot is a boxy up here with a certain line in the middle, or like in the box. It doesn't have to be in the middle. And then we have a line up here and a line up here. Okay, so in a box plot, guys, we have the box consists of the quartile. So we have Q2 is in the middle. Okay, so that is the median. That's the median. Then we have this one is Q1. This is called the lower quartile. And this one is called the Q3, which is the upper quartile. Okay. And then we've got two additional things to denote. So this value, the very end of our line, and that one. So this one will be the minimal value of our data sets. Minimum. And this will be our maximum. Okay. So what is nice about a box plot is that we can visualize data, like how it's clustered. So basically, what is nice about a box plot is that we know that 50% of our data, just let me put it in blue, 50% of our data is in here. Okay, 50% is in here. 50% is, 25% will be here, and 25% will be here. And the median splits the data in half. So here we've got 50%, and here we've got 50%. So that are the crucial things to know about box plots. Okay, so just remember, in the box we've got 50%. The box consists of Q1, Q2, and Q3. Then we've got the minimal value and the maximum value, and we've got 25 up here and 25 up here. Okay, so it just shows how much data is around your median. That's why we denote the Q1 and the Q3, the upper quartile and the lower quartile, to just get a sense of how our data is distributed. Okay? So, what do they say? For this data set, write down the value of the median. Well, now it's easy, isn't it? Because the median, as we just saw, the median is Q2, and that's the middle value. That's this one. That's the value, the line in our box. So that's the median, so that will be 10. You see? That's 10, because that's this value. The upper quartile, so that is this one. That's the right part of our box. So this is so this was Q2, that's also the median. This is Q3, that's the upper quartile, that is 12. And then the minimum value. Well, the minimum value, as I explained, this is the minimum, this is the maximum. So the minimum value is 1. You see? So this is 1. Okay, great. So this is good to know about the box plot. This is what you need to know. So get familiar with it for the tests. And don't forget these values. And then lastly, write down 3 different integers whose mean is 10. Okay, so what is the mean again? Mean is like the average, right? So if we have, for example, 1, 2, and 3, the mean of these values will be, So we denote it like this often. That's the mean. That will be the sum of the 3 elements, 1 plus 2 plus 3, divided by the number of elements. So we've got 3 values. So that will be 6 divided by 3, so that is 2. So that means the average number is 2. It's a coincidence that it's the second value. It doesn't have to be, okay? Okay, so that is the mean. And now they say write down 3 different integers. So what is an integer? An integer is like -3, -2, -1, 0, 1, 2, 3. Any whole number, but it can be positive or negative. Whose mean is 10. Okay, so we need 3 values. We need 3 values. And then we know that the mean is 10. So the mean will be the sum of the 3 elements. So let's say x2, x2, x1, x2, x3. So it's the sum of the 3 values. Oh, is it working? Yeah. So x1 plus x2 plus x3 divided by 3 because we've got 3 elements, and this must be equal to 10. Okay? Write down 3 different integers whose mean is 10. Okay, so what can we say now? If we are a little bit tricky now or a bit smart, we are looking for those integers, right? But we know that divided by 3, it must be 10. So if we now multiply both sides by 3, we can do that with an equation. We can just multiply both sides. We get that those 3 eliminate. So we get that x1 plus x2 plus x3 must be equal to 30. Okay, so basically, guys, if we need 3 integers whose mean is 10, that just means that the sum of the integers must be 30. So then you can pick anything. You can, for example, pick 3, 17, that will be 20, and then we have to add 10. Or we do 10, 10, 10. But it could be integers, right? Let's double check. Yeah, integers. So it could also even be negative values. So it could be, for example, -3. Then we do 23. So together that makes 20. And then we add 10. You see? So if you just have to give one set of numbers, write down 3 different integers whose mean is 10. So you can just pick anything. You can just pick this one, for example. Pick anything whose sum is 30. That's important. And this is the last question. Write down thingies. Okay, so summary of what we just did. Remember that the difference between continuous and discrete. With discrete, we are counting. That was with the binomial distribution, for example. And continuous, we are measuring. So that is more what we see in the normal distribution. Then the box plot, again, as I explained, Q2 is in the middle. That's the median. Then we've got Q1, Q3, they form the box, and then we've got the minimal value here, the maximum value there. And we know that 50% of the data is in here. It's not asked here, but you may have other questions related to it. 25 will be up here and 25 will be up here. And the median splits the data in 2. So if our median is in here, then we will have 50% of the data on the left side and 50% on the right side. All right, see you in the next video. I hope this helps. See ya!